Bob Friday. He is the co-founder and CTO of MIST Juniper Networks, and he will be speaking today. Thank you, Bob.
Thank you. Thank you, everyone. And I'm supposed to announce there's someone walking around with $25. All you have to do is scan some QR code, and you'll get a $25 gift. There he is, gentleman in the back. So thank you for coming. If nothing else, there's a $25 gift certificate in here. So anyway, my name is Bob Friday. I have made a career out of, for those who are familiar with the unlicensed bands. So I send the FCC a Christmas card every year because basically I've done 3 startups, paid for houses, kids' colleges, basically making a living off this unlicensed wireless band. And today I'm going to be here to talk about a little bit about AIOps, what's going on in the campus access networking, talk a little bit about CBRS, and talk a little about indoor location. So as I said, one of my companies I sold to Cisco. I was a Cisco mobility CTO for about 8 years. And one of the things I did there, I would say back in my, let's see how many campuses, this looks like a fiber show, but I hope a few of you are working on the access network in your campuses. Do I have anybody here on the network side? A couple people? Okay. So back in the early 2000s, I did a startup called Aerospace. That startup was really focused on helping enterprises and higher ed on managing boxes. I sold that one to Cisco. And when I was at Cisco, what I started to see, we started to hear wireless going from a nice to have, then it went kind of this must have. At Cisco, I started working with higher ed, retail, and they started putting more critical things onto the networks. And this is when I saw this paradigm shift. Really shift from helping people manage boxes to really, they really wanted help on managing the end-to-end user experience. It was very clear when I talked to a couple of big retailers. It was like, hey, Bob, before I put anything, put a mobile app on this client, you've got to stop your controllers from crashing. They were tired of controllers crashing all the time. They wanted faster innovation. Instead of having 1 release a year or 2 releases a year, they wanted to be able to release every week or so, right? They were basically, all their mobile app designs were going to this agile process. And 3, they wanted visibility. It wasn't good enough to know that the access point or the switch was up and running. They really wanted to know, did the user really have a good internet connection? Is that mobile app going to work? And so that is the reason I started MIST, was really to focus on this paradigm shift around AIOps, really ingesting data from different points in the network. Ingesting data from the client side, the access point side, the switch point side, and even the router side. The access point is a good place to start if you're trying to answer the question of why is a user having a bad internet experience. The access point has a lot of the data you need to answer that question. Since I've been at Juniper, we're starting to work on the router side. What the router brings to the table is all the application session information, right? So now it starts to help answer questions of why you're having a bad Zoom experience. And so this is the journey I've been on for probably the last, I left Cisco in 2014, 15, so about maybe 7, 8 years now, of really see if we can't build something that can manage and troubleshoot networks on par with IT domain experts, right? Can we build something that really helps IT departments offload some of the pain of managing and operating these complex networks they're getting into? Now, this slide here is kind of somewhat of a bragging slide, but the real point of this slide is to highlight, the fact that I went from my kitchen, started MIST with a blank sheet of paper in my kitchen. In 6 years, we went from a blank sheet of paper to being a leader in this Gartner MQ. And what this really highlights, I think, is really the architectural change between cloud and AI. When you look at what's going on in these network architectures, it kind of started with Meraki. With at Cisco, we acquired this company called Meraki. That was the kind of the beginnings of the value of cloud managed. And what the cloud really brings to the table is really this innovation of speed, right? It's a different software architecture. It's just a better way to develop and manage software. So from your side of the table, what it means is bugs get fixed faster, features get fixed faster, things don't crash when you get into these cloud architectures. The blast radius is much smaller. When I do things on RM location, it doesn't screw up my network connectivity. They're all little microservices, very cleanly isolated with APIs. So we're basically moving from what I call spaghetti code on the controllers. For those who had controllers back in the old days, we're moving from that spaghetti code architecture to a much more structured cloud architecture. And then on the AI side, this is fundamentally what's changing how we manage these networks, right? This AIOps is really that paradigm shift from we're not here to help manage boxes, we're really here to help manage your students and your professors, right? That end user experience that actually people are using your network for. This is kind of my journey slide. Interestingly, when I started Mist, the question was, should I build an access point? Everyone thought I was crazy. It's like, Bob, the world does not need yet another wireless company. There's plenty of wireless APs out there. But the reason I ended up building an access point was I wanted to make sure I could get the data I needed to solve this AIOps problem. Not that I didn't trust Cisco and Aruba to give me the data, but I didn't trust them. I didn't trust all these vendors to actually provide the data. So when you actually start to look at these access points, routers, and switches, they're more than just functional boxes now. They're actually data sources. As we move to this API cloud paradigm, these are actually the sources of data you're going to be using to manage your network, right? We're moving from SNMP. We've moved to OpenConfig. Telemetry is becoming the next big thing people are talking about, is how do we get data out of these boxes to help manage these networks. So that was the first part of the journey. You'll find out that you actually need to spend a lot of time to get the right data. And it starts with what question you're trying to answer. If I was trying to answer why you're having a poor internet experience, I have to make sure I can actually get the data to answer that question. The second thing I found interestingly is once I started the journey, most IT departments, forget the AI, they appreciated the fact that the data was in the cloud. The fact that I had the data and stuck it in the cloud, and I had put it into some framework that I could apply AI, right? I had to have a very structured framework, but I'm going to apply some ML model to it. That's actually the same framework that most IT departments like to see, right? They're like, if you get the data in that format, the average IT team can solve a lot of problems just by looking at the data. The third piece of the journey, I'll talk about this a little bit more, we all are using the same ML models. For people who are into data science and stuff, there's a very classic, convolutional networks, LSTM. We all have access to the same ML models that are out there. It's really the team. You got to get the right team together to actually make use of these models and combine them with the networking domain experts. And then the other piece is really around this conversational interface. I was given a very hard time about putting this in the product. It's like, Bob, why do we need more? We have plenty of dashboards here. I think we all know we went from kind of the CLI world, then came kind of the dashboard world. I think NLP, conversational interfaces, will be the new interface into your network. Things are getting so complicated right now, you need some way to basically get to the data and the problem more quickly. And this is what these conversational interfaces are going to be helping to do. You're going to be asking questions like, why is Bob having a problem? Why is John's team's not working? Why is the School of Electrical Engineering down? And you want someone to get you want some help on getting to the data. You want to either get the answer or you want to get to the data, the relevant data very quickly. And then finally is this self-action. And this is what I've been optimally working on is, when do you ever get to the point around trusting, when I work with most IT departments, let alone trust some piece of AI code, they barely trust the new intern, right? Not many IT departments trust anyone to touch their networks. They're like, once they get things up and running, they don't want anybody touching that thing. So this is the next piece of code is, when do you trust your AI assistant when it tells you there's a bad cable? Are you going to trust that AI assistant to actually issue the support ticket to fix it? If it tells you there's a misconfigured VLAN, are you going to trust it to actually reconfigure it? So that's the next phase of the journey, is what I call trust. How do you build trust in your AI solutions with the IT teams? This is an example of what actually goes under the hood. People always ask me, what is really the difference between AI now I mean, how can you tell the difference? What's AI? We've been automating things for years. Most of that stuff you see on the bottom down there, machine learning, these are all things that we've been using for 20, 30 or more years to help automate and solve problems. I would tell you the big difference that's come since 2014, since I've been involved in this, are things like LSTM. These are these deep learning models that we know what the convolutional networks did for self-driving cars and medicine, all this convolutional stuff. For us in networking, these time series LSTM models, what they're doing is solving problems like anomaly detection. They're actually getting to the point where the false positives are getting to a percent. The problem with all this anomaly detection in the past was with ARIMA, it was like 80%. And no one wants to be woken up at 3 o'clock in the morning with a false positive rate of 20%, right? If you're going to wake someone up at 3 o'clock in the morning, you better be pretty darn sure that it's worth waking someone up. So this is where these ML models are actually making a difference in our networking space, right? Where we're basically applying them to actually solve problems on par with humans. The other piece, when I left Cisco, it was clear to me that, if I was going to do this, I was going to be an architectural change, right? I wasn't going to go up against Cisco and Aruba with some new feature set. So the thesis of the company was, cloud is a big architectural change, and AI was a big architectural change. That basically required a bunch of real-time pipelines. This is your Kafka, your Flink, your Storm, all these cloud technologies that you need to use if you're going to build something that processes data in real time. The other piece I didn't fully appreciate, and when I got into it, was organizationally. By starting with a blank sheet of paper, I was able to organize the company. I was able to make sure that the data science team was tied right to the hips of the customer success team. As you start to move to the cloud, it starts to turn out that actually the missed success team is basically the customer. There's really, everyone has access to the same data. Once everything gets moved to the cloud, my customer success team, your IT team, we all have visibility. When you call up the IT team, there is no need to start sending files and everything, right? All that data is already there at everyone's fingertips. And so the thing here is really, and they're the domain experts. That success team at MIST, these are guys who understand the network. The data scientists are the guys who understand all the fancy math, right? Those are the guys that, they know how to solve problems, but they really don't understand switching, routing, and wireless. So that was another key piece of success, is getting that team to use this AI assistant every week. For every trouble ticket that comes into MIST, that customer success team basically is using Marvis to try to see if Marvis can answer the question. And this kind of shows you the journey of what the last 4 years have been like. I think when I started this, 2017, yeah, it's been about 5 years now, of every week basically seeing if Marvis can help answer a question. And what the blue and red indicate, those blue and red bars, that tells you how often the AIOps actually got the right answer or helped the IT team get to the right answer quicker. The orange line indicates, did I have the data? It took probably, I'd say, a good year or more. You see that orange stuff up there on the left? That's basically just saying, hey, we don't have the data. We got, the data that I need is still left in the switcher or the AP. So you spend a lot of time on the journey just getting the data back to the cloud, trying to get that done. And that probably took a year or so. And that's why I built the access point, because I knew that once we got into it, that getting the data from the AP or the switcher router was going to take time and effort. Because I have to go touch, that's embedded code. I have to go touch that code and basically get that data out and sent back to the cloud. In the higher ed space, I would say, at Cisco, I worked a lot with higher ed. I would say higher ed is probably an interesting space because they have a very demanding user group. Besides a bunch of students coming into campus every quarter and overloading your network, going from 0 to 100, in in a day. You also have professors. I was just at a university out in Atlanta, and you got some very demanding professors usually in campuses. There was one professor who basically said he wanted 10 gigabits per second wireless. And he didn't understand all the problems, but that's what he needed for some of his R&D work. So that is kind of the need for even higher ed is starting to get more pressure on higher performance wireless. The fiber, as the fiber goes up, they want that extended all the way out to their mobile wireless edge. I would say the other thing I've seen is common from the people who are transitioning from controller to cloud is the whole software upgrade maintenance. I've seen the IT teams really are not getting the headcount just to keep up with upgrading software on controllers and APs. That whole mechanism is really starting to become a burden. And that's back to that cloud, right? That's back to, by moving that function back into the cloud, you're getting rid of that whole software upgrade cycle. That whole problem is being moved from your campus back somewhere else in terms of how we maintain and update, keep software updated. This is kind of what we're seeing, when actually people who have gone down this path. I've worked with MIT, Dartmouth, Georgia Tech. And I think the general theme is this time. The general trend is most higher ed, which is true even in most enterprises. Yeah, the IT teams are getting smaller. They're not getting bigger. There's more pressure to do more with less, usually in the higher ed space I've seen. And this is why they're trying to basically get more assistant, right? They're trying to move that software upgrade problem away. They're trying to get more visibility all the way down into the user space, from the students and the professors. So that's kind of what I've seen on the AIOps side. The other thing the other thing I wanted to touch upon is CBRS, private cellular, because this one reminds me about the early days of Wi-Fi. See, anyone here looking at private cellular, CBRS type of stuff? This reminds me of the early days of Wi-Fi. Is this going to become a must-have? It's definitely, everyone I've talked to has tried it out. It's either it's in their toolbox or they've got it in the lab. A lot of people don't quite know, they haven't quite found the business use case, especially in higher ed. I'm working in a few higher eds right now, being interested in talking to people who are playing with this right now. But it's clear that it's going to become part of the wireless toolbox in some form or fashion. I think what's clear is after talking to everyone, especially in remote learning, there's a lot of money coming down the pipe for remote learning around campuses. I've got cities and campuses and schools seem to be teaming up on this for underserved areas or in remote areas. So remote learning is one of the key use cases I've seen. The other one I've seen is just neutral host. If we ever get the operators to agree to roam from a private cellular to a public, from a public cellular to a private cellular, it looks like CBRS is going to become a better version of DAS. And this may be what drives it from a nice to have to a must have, is neutral host. So that one there, I'd be interested to see what anyone else is seeing, and catch me afterwards if you want to talk about CBRS and private cellular and what we're doing around AIOps. Right now, we're basically working on converging Wi-Fi and cellular together. This is the use case. Students start on Wi-Fi and then they go home and end up on CBRS. So now we have users moving between private cellular and private Wi-Fi type of networks. The last piece of the puzzle I work on quite a bit is indoor location. This is something I've done since I think all the last two startups. I've always had an indoor location. It's relevant to higher ed because you always have students. There's always a facilities management or a student aspect coming on location. And I've been on the mission right now lately to basically reduce the friction points on being able to adopt indoor location. We did that by basically making sure that every access point we ship is converged connectivity and location. And so inside every access point is this BLE array to basically give you better location on the array side. And the other piece I found is location doesn't drive the application, but there's a bunch of companies now where even on the higher ed modal labs, we're starting to see a much more, the application is becoming more prevalent even in higher ed for students. So we're starting to see that take place inside the location area. And these are kind of the use cases we're seeing on the higher ed side. I'm working with a couple higher ed customers, and it's really around trying to provide either location, some sort of wayfinding activity around helping people get around the campus or around the departments. Stanford Law School does something similar to this. Or it's around some sort of asset management. They have assets like laptops. We're starting to see use cases now where they're trying to make sure they can find lost laptops, find the last place that laptop was located. And this is coming, I would say catch me up. There's a couple of universities, University of Texas and Arlington is one working on this. This is another area I'm interested in. And with that, I would recommend, all these topics are dear. Anyone who wants to follow up, please reach out to me. You connect me on LinkedIn, AIOps, CBRS, location, all things I love to talk about. So with that, I'll turn it over to the next speaker, and thank you, everyone. Or any questions? I guess we have a minute or two for questions. Are there any questions about any of those topics?
Got a quick question for you, Bob. George Peak from UCSC. So I've actually had a chance to use the MIST APs, and I also come from wireless background. Well, not as much as my coworkers, but using the WILCs, pretty much going back ways. So one thing I noticed is that there's not a functionality match between what I can do, for example, on the controller side on the WILC or using products like DNAC from Cisco, to what I can do, for example, on the MIST side. Are there developments taking place to be, I guess, more capable as an enterprise product? I know it's very cloud-driven, so there's only so much you can do.
So the question is there more enterprise capability being driven into the MIST product?
Planned.
The plan? Yeah. So I would say, how do I answer it? So the answer is right now, MIST right now is in over half the Fortune 10 companies, Walmart, Amazon, UPS. All those companies were basically won with enterprise features, right? That was up against Cisco and Aruba. So I would say, to that question there, we win all these enterprise deals on features. Enterprise features.
Right. Okay. Thank you.
Yeah.
Hi, Bob. Really interesting work. So I'm Mariam. I work as a research scientist working in self-driving networks for the DOE networks.
Okay.
So I had a question about the self-optimization thing which you guys are doing. Do you find that working with different organizations, the requirements for the network to be optimized are different? So are you optimizing on different factors like throughput versus latency? Or
I would say there's a team inside of MIST right now that focuses on radio resource management optimization. They're actually using this K nearest neighbor algorithm now to basically try to organize the configuration based on the type of user, type of network, right? I mean, so if you're a retailer with high ceilings, line of sight type of space, that requires a different configuration. If you're a school with big auditoriums and hallways and everything, that requires, so the answer is yes, they're trying to basically optimize things where you basically classify or cluster you by what type of network you're in. And that's part of the power of this global training, right? Once you have a big enough network, you can basically start characterizing networks because we have enough customers right now, so that's the label data. Does that answer your question?
yes, thank you. Yeah.
Yeah.
Final call for questions?
No private cellular questions? Anybody out there? Let me get my private cellular question in and see if you.
I'll ask a very naive question. But on CBRS, the issue that we've seen is roaming is difficult amongst various CBRS systems. And to your point, the handover between public and private networks is still a puzzle that hasn't been solved satisfactorily. It's not seamless, if you will. I was wondering if that's a naive question, an informed question, or a right to question. So.
Yeah, I mean, so on CBRS roaming now, I don't know what vendors have you tried vendors? Have you tried it? Have you tried a couple CBRS vendors yet? Yeah, the roaming. I mean, the roaming in theory should work. I mean, the roaming should be on par with cellular. I mean, this is basically CBRS is basically band 48 of a cellular. I mean, in the sense of there should be no difference between a private cellular network and a public cellular network in terms of roaming. The neutral host problem is a business problem. That's basically getting Verizon, T-Mobile, and AT&T to agree to roam onto a private cellular network. But yeah, I'll follow up with you because in theory you should, if you have a private cellular network, it should roam as good as your public cellular network. And I'm working with a couple of healthcare, on the theory that private cellular should be better for voice. The roaming coverage should give. Yeah, see that doesn't sound right. I mean, in theory, it should be it should be just like your cell phone. It should be it should be seconds. It should be much quicker than Wi-Fi. It should be because they're the networks making the roaming decision.
Are you seeing a bigger adoption in the future in laptops and iPads being capable of actually using CBRS?
Yeah, well, I've talked to Dale, for like Seattle public schools. For the schools who hand out laptops to their students and stuff, Dell now has CBRS built into some of these laptops now. Laptops or Chrome notebooks.
That's the future.
Yeah. All your phones will support CBRS. I think iPhone i14 supports it because, like I said, it's band 48. It's just another cellular band as far as the phone is concerned.
Anyone else?
Okay.
We got one.
Almost. So my name is Spaggy. I work for the Hoopa Valley Tribe under their public utilities district, and we've been doing fixed wireless for some time. We're just stepping into the CBRS realm for that. One of the things that we wanted to do as a tribe is create like our own LTE network so that we can have like a tribal cell phone service. Because again, Verizon, T-Mobile, and AT&T only invested in one area of our tribe and they consider it done. So we wanted to do something like that. Does Juniper offer like a CBRS kind of antenna within their wireless routers, or is that ever something to do like a mix of Wi-Fi and indoor?
Juniper does not build a CBRS radio yet. Right now we work with partners right now integrating CBRS and Wi-Fi together so we can kind of move between them seamlessly and provide kind of an operational, we're not trying to manage the CBRS, but we're trying to provide a operational viewpoint from an AIOps point of view. Okay. So you can actually, if someone calls you up and says, the classic story is someone says, hey, the mobile app's not working. The next question is, well, what network? And they're like, I don't know. I just know this app's not working. So the first problem is, can we just figure out what network this person is on? I would tell you the other thing, if you're headed down the CBRS, there's two flavors. There's what I call the Soluna do-it-yourself cloud managed flavor, kind of like Miss Meraki Wi-Fi. And then there's the Nokia service provider, turnkey, more complicated, I want someone else to take care of the problem. Yeah, and have you tried out any of these things yet?
So the platforms that we're looking into were like a broadband only one from Cambium, which was the Medusa platform. We recently were connected with Telrad as well. And the do-it-yourself route was going to be putting a open source EPC on a server and using buy-sells gear to try and get get it done ourselves. But
I'll introduce you to the guys at Utah. There's the do-it-yourself gang. That is the true do-it-yourself gang. It's like we'll get some open source code and do it.
Appreciate it.
All right, folks, we're at time. Thank you, Bob.